Now we are going to do 3 examples of when we are given a triangle, a diagram on the Cartesian plane, and we need to go find certain values, like for example, in this case, sine theta, cos theta. Then in the next video, we are going to do similar questions, but there we're going to have to go draw our own diagrams. Okay, let's jump in. We've got this. It says refer to the diagram below. We can do that. And then without a calculator, determine the values of. And then we've got 4 different things that we need to answer over there. Don't use a calculator. Students just kind of go off on their own tangent and they just try and find theta, but that's not what we're asked to do. So on the diagram over there, that is our x. Our x is 3. Our y is 4. Okay. Let's go do this. Towards the x-axis, we go and create a 90-degree triangle. Where are we going to use that x? Well, that x would represent that side length over there, and that y would represent that side length over there. Okay, we've got a 90-degree triangle. We can go find our hypotenuse by using the theorem of Pythagorean. Well, why do we need it? Well, if I look at what we're supposed to find in A, sine theta, to get a value for sine theta, we need to use the opposite over hypotenuse. So we need that hypotenuse. Let's go find that using the theorem of Pythagoras. So the shorter 2 sides, my 3 squared, plus my 4 squared, will be equal to my hypotenuse square. And in this case, since we're on the Cartesian plane and we're working with the unit circle, I'm just going to make that r squared. But if you made that an h for the hypotenuse, that's perfectly fine. And we are using the theorem of Pythag. Okay, let's simplify that. So that would be 9 plus 16 is equal to r squared, 25 equal to r squared. And therefore, our r, I keep doing these silly things. Therefore, our r would be equal to 5 because we are going to get the square root on both sides. Okay, so we've got our hypotenuse is equal to 5. Now that we've got all our side lengths, we can start answering the questions. So for A, if we have to find sine theta, well, sine theta is equal to opposite over hypotenuse. In this case, the opposite, if we are positioned there by theta, opposite is 4 and my hypotenuse is 5. And that is literally our answer. They don't ask you for theta. Don't pick up your calculator and say shift, sine, blah, blah, blah. No, we're done. They asked us the value for sine theta, and sine theta is equal to that. Know when to stop. Okay, B, cos theta. Cos theta. Well, cos theta is equal to adjacent over hypotenuse, and we are done. We answered the question. We used our diagram and we found the value of cos theta. Tan theta. Well, tan theta is equal to opposite over adjacent. Opposite over adjacent. We are done. That's what they asked us to do. Last one. D. Negative tan theta. Take away sine theta. Well, we already have the value for tan theta. We just wrote that down. So let's just plug that in there. So that would be negative, and then tan theta is 4 over 3. And then take away, we already have the value for sine theta. It is equal to 4 over 5. So now we just need to use our fraction knowledge. So if we simplify it from there, we need to, since we are subtracting fractions, we need to make our denominators the same. So I'm going to make it 15. Then I'm going to multiply that one by 3. So I'm also going to multiply that one by 3. Do you see what I mean? Obviously for this part, if you get your, no man, I'm multiplying it by 5. Sorry, I'm multiplying it by 5. I'm multiplying it by 5. You saw that mistake, hey? All right. And then this one I'm going to times by 3, and that one I'm going to times by 3. So that would give me that. And then we simplify that one step further. that would give us negative 32. And that's it. That's the value of negative tan theta, take away sine theta. Next question. Refer to the diagram below and without a calculator, determine the values of, and then we've got 3 questions that we need to answer there. All right, do you see that with this one, we are in the second quadrant? So let's just quickly go and create a 90-degree triangle for ourselves. There we've got our x, there we've got our y, and we notice, obviously it makes sense in the second quadrant that our x value is obviously negative 5. I'm just going to go put it there as positive 5 though, because there it represents the side length of my triangle, but when we use it, we are going to use it as negative 5. Okay, so just track with me. That will make sense as we go, I'm sure. Then this one over here, there we've got, that one over there is 3. Perfect. We don't have our hypotenuse. We can use the theorem of Pythagoras to work that out. Now, also just note, grade 10s, if you haven't watched the video on introducing like these angles that form on the Cartesian plane, then I would suggest to go watch it, because in that video I explain why we can actually just write that theta over there as well, if it is given like that those two things would actually be the same. So then it would make a little bit more sense, because if you look at that, you're like, but they're not the same. The one is acute and the other one is obtuse. So I'll also put a link to that in the description. Okay. So we need to use the theorem of Pythagoras to get the hypotenuse. Why do we need the hypotenuse? Because for B, we have to go write down sine theta, and for that we need the hypotenuse, so we definitely have to go do that. So for our theorem of Pythagoras, the shorter two side, 3 squared plus 5 squared is equal to the hypotenuse squared. You can use an h for hypotenuse, and we're using Pythag, so that would give us that. And then I think that would give us that. And then I'm just going to go get the square root on both sides. And then we get that r is equal to the square root of 34. Not a perfect square. Obviously, we can go put that into our calculators, but I'm just going to leave it like that. I'm just going to work with that as is. Then we don't have to worry about rounding and all of that. Okay, so we found that. Oh, I think that was actually the first question. So that would be our origin, our O, and there is our point T. So that was actually A. Okay, so that was finding that. Answered the first question. Let's look at B. For B, we need to find sine theta. Well, sine is equal to opposite over hypotenuse. So we've got 3 over square root 34. Since it is without a calculator, I am just going to leave it like that. And I take back what I said with this one. We must leave it like that because otherwise we need our calculators to round that off and get decimals. So just work with it like that. So there we got the answers for sine theta. Now watch out. They don't want you to go find the angle. We need our calculators to do that. And they specifically said it's without a calculator, and they never said they want theta. They said they want the value of sine theta. And we found that. Let's look at C. Now they want us to get tan squared theta. Well, what's very important that we need to take note of, tan squared theta is, it means the same. It means that tan theta, whatever that is, needs to be squared. And the same thing, if we've got something like sine squared theta, it means we've got whatever sine theta is, and that needs to be squared. So in this case, we are going to get the value for tan theta. Tan would be opposite over adjacent, so that would be 3 over negative 5. Remember, we're in the second quadrant, and we know, according to our cos diagram that we just used to help us, we know that in this quadrant only our sine ratio will be positive. And we can see that there, our sine ratio is positive. And we can see over here with this one that our tan ratio is negative. So be mindful of your signs. But then we're going to square that. And then it will become positive. So then it will be 9 over, and that would be 25. And that's it. We're done with the question. So why is it positive? It's because it is tan squared theta. Once again, refer to the diagram below. We are given point P is equal to that. Okay, so they did not indicate that on the sketch. So that is the point X and negative 12. All right, without a calculator, once again, determine the values of, and then we need to answer all those questions. Let's go and create a 90-degree triangle for ourselves there. Again, I'm just going to make that theta over there. And again, refer to the video where we introduced this section if you want to have a better understanding of that, and I do recommend it. Okay, so theta is there. We are based there in that acute angle. Our hypotenuse there is 13. And then let's make sense and see what else we've got there. We've got our y value over here. So this one over here, this side length over there, I'm just going to put it as positive 12 because it represents a side length. But when I use it in my ratios, I'm going to use my negative 12 because in the third quadrant where we are in at the moment, there my y values on the Cartesian plane is negative. And let's just quickly make a prediction, shall we? So for our cast diagram, let me just make a rough sketch over here, our cast diagram, which just helps us determine the signs, right? So in the third quadrant where we are in, the only ratio that will have a positive value will be tan. So sine would be negative, cos would be negative, but tan would be positive. And if we don't get it like that, we need to check our signs and make sure that we didn't do anything wrong. So what we are missing in this example is this over here, our adjacent side, our x value that we were not given. All right, and that is also the first question. So for A, it says that we need to go find x. And again, we can just use the theorem of Pythagoras. So our x squared plus our 12 squared is equal to the longest side squared. If your Pythagoras looks slightly different than mine, that's perfectly fine. And then x squared is equal to 169 minus 144. I'm just simplifying that. And then x squared would be equal to, that would be 25. And therefore my x is equal to 5. All right, perfect. So we just found that one to be 5. But now we also need to think. So now we found the whole point P. Let's just complete it. This one is negative 12. Will my x be positive or negative there? Yes, we found our x to be positive 5, sure, using Pythag, but we are in the third quadrant where my x values will be negative. So this will be negative 5. That is very important, and that is a common mistake that I see students make. Okay, for B, now we can go find the value of cos theta. Theta, cos is equal to opposite over hypotenuse. Note that. So the cos ratio is negative. Does it make sense considering the cos diagram? Yes, it does. I hope it does. Okay, C. 1 minus sine squared theta. Well, in the previous one, we also just said that that means 1 minus whatever sine theta is, and then we need to square it. So 1 minus sine theta, sine's ratio will be opposite over hypotenuse, and then we need to square that. Let me just carry on over here. So then it would be 1 minus, and then if we square that, it will become 144 over 169. And then if we simplify that further, it would be, I believe, 25 over 169. And how did I get that? You just make your denominators the same. So in other words, that 1 will be written as 169 over 169. And then we'll just subtract those two. So I do believe that that is the right answer for C. D, last one. Now we've got the value for tan theta plus cos theta. Tan theta, the value for that will be opposite over adjacent. So we replace that with opposite over adjacent. opposite over adjacent, plus the cos we already worked out in B. Do you see why our tan there is positive? Because it's that negative divided by negative, which will give us positive 12 over 15. And then these two will mean that we are going to subtract that. And then we are going to subtract 12 over. That's not a 15. That should be a 5. Yeah, that's better. And 13. And now we need to make our denominators the same. So this is all fractions. I'm just going to multiply those two together. 5 times 13. And that gives me 65. And then I have to multiply that one by 3 and that one by 3. And this one by 5 and that one by 5. And yes, I am using my calculator just to help me there. I'm still showing all my steps. The idea without your calculator is that we don't use it for the trick, like to find our theta. Minus. And that gives me negative 24 over 65. All right, in the next video, we're going to draw our own diagrams.